All right, welcome to the quick tutorial, hopefully it's quick, on law of sines and law of cosines. So I gave you the two formulas in class. You can use those as we go through this video. I'm not going to rewrite them again, but we will decide when we're going to use law of sines and when we're going to use law of cosines based on the information that we're given. So to begin with, we take a look at do we have an angle and a side across from that angle that are both given to us? And if we do, then we can use law of sines. So when I look at this triangle, I see that I have two angles and a side. Well, if I have two angles in a triangle, I can most definitely find the third angle. So all I'm going to do is add the two angles together that I have and subtract them from 180, and that's going to give me that angle B is 114 degrees. So now I've got that angle B. Now I'm going to make myself a little list over here of what I've found, so that I make sure I find everything that is required in this problem. So the other two pieces I have to find are little a and little c. Now remember, that's just because angle A across from that will be little a, side A, and across from angle C will be side C. So those are the other two things I have to find. So I'm just going to write those down so I don't forget. I'm going to use the law of sines here. And the reason I can use the law of sines is because I know an angle and a side right across from it. So the law of sines, I'll write it here for you, just in case you did not write it down when we were talking about this in class, is the sine of an angle over the side across from that angle. And the really beautiful thing here is that that ratio remains consistent through the entire triangle. Okay, so what I'm going to do is I'm going to look at the fact that, hey, I know angle B, and I know, we'll better label that little b. I know angle B and little b, so I know I'm going to use this ratio. All right, so I'm going to start off by setting up that ratio. So sine of angle B, which is 114 degrees, over little b, which is 31. Now the second thing I'm going to do is try to figure out which angle to find, or which side to find after that. Now because I have both of these angles, I could really use either one to set up my second ratio. I don't care which one, so we'll just go with A first. So I'm going to use the second ratio is going to be angle A and little a. So I'm going to say the sine of angle A, which I know is 34 degrees, over little a. And now I just have a proportion, right? So I can cross multiply and find the missing piece. So if I cross multiply, I'm going to have A times the sine of 114 degrees equals 31 times the sine of 34 degrees. And there's my equation. To solve this equation for A, I'm going to divide both sides by the sine of 114 degrees. Keep forgetting that second one there. So divide by the sine of 114 degrees. And then that's going to just give me an expression for just A. And then I can just type that expression into my calculator. Watch a couple of things. When you type sine into your calculator, it's going to open up a set of parentheses. Just make sure you close that before you divide by the sine of 114. So go ahead and type that into your calculator and see what you get. And I think you're going to get 18.97. Okay, so that's the measure of little a, 18.97. Now at this point, to find little c, you would just go through this entire process again. And I would start it exactly the same way. I'd start by sine of 114 degrees over 31. And I'm using that information because I knew that to start. You don't, if at all possible, want to use what you just found to help you find something else. Because if you did make a mistake, it's just going to compound that error. And then I would just do sine of angle C, which is 32 degrees, over little c, and then the same process. Go ahead and see if you can solve that one and come back and check your answer. All right, and you should get 17.98 is a good approximation. All right, let's try one more. So this is another one with the law of sines. And the first thing I'm going to do is I'm going to label all of my sides. All right, so across from angle A is little a, across from angle B is little b, and across from angle C is little c. So we only know one angle in this problem, but we do know both an angle, 34 degrees, and a side across from that angle. So that's good information because when we start setting up our law of sines, we're going to use that to help us. So remember, law of sines is sine of A over little a equals sine of B over little b equals sine of C over little c. And I know I'm going to use that ratio that has b in it first because that's the information that I have. So let me start out by writing that. Sine of b, oops, I guess I can write in the angle we have for b, 34 degrees over little b, which is 20. Okay, so now I have to decide what I'm going to do from there. Well, I don't have really a lot of options because the only other piece of information that I know is little a. So that means I'm going to have to set up a proportion using that second ratio as a. So I would have the sine of a, which I don't know, over 14. Now I've got another proportion. So if I cross multiply, I'm going to have 14 times the sine of 34 equals 20 times the sine of a. Now this is interesting because I'm trying to solve for the angle A. So there's two steps to this. The first thing is I'm going to have to divide both sides by 20. All right, so I'm going to divide both sides by 20. All right, that's going to give me just the sine of A is equal to, now we have this expression, 14 times the sine of 34 over 20. So remembering that we are solving for an angle here, right? We have to undo sine. So remember how we undo sine is by taking the inverse sine of both sides. So when I take the inverse sine of both sides, I'm going to have something that looks like this. The inverse sine of that whole expression. So 14 times the sine of 34 over 20. And that's just going to be equal to angle A, because we're going to take the inverse sine of both sides. Now, you could write that out just like I did in class a couple days ago, where we said the inverse sine of the sine of angle A, right? And then what happens is the inverse sine undoes the sine, and you're just left with A. Now, at this point, it's a matter of just typing it into your graphing calculator once again. So go ahead and type that in. You can do this in multiple steps if you need to, but make sure you're following, parentheses. You're going to need a large set of parentheses around this entire fraction, but then you're also going to see that when you type sine in the middle there, it's going to open up another set of parentheses that you'll need to close before you divide by 20. Okay, type that in, see what you get. So I got that A is about 23 degrees. Okay, so that's awesome. Now I know that angle. So there's really only one set of things left to find. Now, to find the missing angle, that's really simple, right? We can just, oops, that's not a highlighter. We can just subtract what we have from 180. So to find angle C, I'm just going to subtract 34 and 23 from 180, and that's going to give me 123. So I know that angle C is 123. I'm going to write that over here as well. And then all that leaves is little c. Now I would go ahead and just set up another law of sines problem here, right? And using the information that was given to us at the start, which is all that information about angle B and the side across from angle B. And then at that point, you can just but you can just write sine of 123 degrees over little c. And then you would solve this just like we did in the previous example. Okay, if you'd like to see what the answer to that is, try it yourself, pause the video, and come back and check. Okay, and just to check real quickly, I didn't do all the work, but you would get approximately 30. I think it's like 29.99575. So no matter what you rounded to there, you're going to get around 30. Okay, that's law of sines. Check the second video for law of cosines.